Just kick the microphone. That's a good way to start. Hello, everyone. I hope you can hear us, or else this is going to look really weird.
I think we are live.
Hey, everyone. It's Ricardo here, and once again, I'm here with Paulo, one of our
Hi, guys.
sorry, one of our Amplify Shader Editor developers and resident shader wizard. So yeah, guys, it's good to be back. We're back from our short holiday. We were away for like half of December, so we took that time to get some rest and really recharge our batteries, right?
Eating a lot of chocolates, of course.
Sweets, of course, lots of sweets. So we hope you guys also had a nice holiday, a short holiday, but a nice one. And we're really excited for this year. We have a lot planned for Amplify Shader Editor. Amplify Imposters has some features coming up. Paulo here is preparing a new update with some cool stuff.
Yeah, an old one actually. But yeah.
But it's coming soon,
yeah.
Soonish. But yeah, and for Amplify, the actual editor, we do have some stuff planned. So you might want to stick around our Twitter or Discord because we're going to start talking more about it in the following months. Last but not least, we also have our Amplify Painter, which I hope you had some chance to play with during the holiday. That's also going to ramp up and development speed this year. So it's really something to keep an eye on, and we're still open to feedback during this stage. So if you have any suggestions, requests, just reach out to us. And today we're gonna check out something really cool. Paulo here has something to show us. You want to tell us a little bit about it before we start?
So you probably already seen, at least in one of our samples for I think it's the SRP lightweight. We have what we call the Omni Decal shader, and that technique actually can be used in lots of different places. And I decided to prepare at least 2 different cases of using that one. So yeah, but again, if you have any questions that you, I don't know, maybe at middle of the session, if you want to ask something, do, or you can stick around to the end and ask not related to this case in particular, but you can ask anything about any kind of shader.
Yeah, we're completely open to everything.
Yeah.
Hey Ryan, welcome. So as Paulo was saying, feel free to post anything you want in the chat, or even use our Discord, and we'll see if there's any questions during the end. So I don't know, do you want to wait for more people to come in, or?
I think I can start at least explaining, setting up the scene.
Out of curiosity, what exactly is an Omni Decal? Does it project in every direction, or can we also control it in other ways?
The Omni here is kind of, it's not actually true. It's not actually projecting in all directions, but it looks Omni because it actually paints in every direction, but it's not actually projecting in all the directions. Actually, one of the examples that I'm going to show us today is the caustics effect, and in that one I'm actually going to project something, but it's not actually on all directions. Just in one planar
decal. That's pretty cool. Yeah, I can see a lot of uses for that. Not just caustics. There's a lot of stylized stuff you could probably do with that. Like you're going to show us some burning embers, I think.
Yeah, I'm going to basically do like a glowing sphere that you can place on a fireplace or a bonfire or something like that.
Or a burning building.
Yeah, sure. We actually use this technique in the curve logos.
Oh yeah, it's that one. Yeah.
I added like a triplanar shader to the effect to do that sparkling fire effects on the burning buildings. Yeah.
So yeah, if you haven't checked out the curve logos, now it's a good time to see it in action. It's in the intro section. But yeah, if no one has any questions before we begin, let's go for it. I hope everyone can see the stream all right. And yeah, I'm gonna switch over to Paulo's desktop.
Okay. Let me just adjust here a bit. Yeah,
so we're starting fresh.
Yeah. There's just at least 2 things that I want to explain here. I only have like a camera, a light, and a ground. My directional light is actually set up to be a little bit less, to have a less intensity from the default one. Mm-hmm. That's because we're going to use some lighting shaders that we want to see the light, and having a darkened environment helps. And I also have on the camera the bloom effect from the post-processing stack. And there's this little script that I'm going to explain in a bit.
Cool.
So this is going to be the final result. So this is the fire. Let me just close these colliders here. So this will be the final result. I do have like a point light here, but I'm going to deselect it just so you can see the Omni effect by itself, as you can see.
Oh yeah.
And
really adds to the effect, yeah.
And there's a particle glow as well. So let's say that I don't have the particle glow and only have the Omni one.
So we need one assets. We need a shader and a custom script to get this working.
Not exactly. So the thing is, you'll see in a minute, but I'm using a technique that actually reads from the depth buffer and the normal buffer. At least for the caustics one, it reads for the normal buffer, but in this one it is only from the depth buffer. And you may have a setup that your depth buffer is not already available to you, and that's why you may need a script to activate the depth buffer. In this case, I actually solved it in a more simple way. I simply use my camera in deferred mode, because the deferred mode already has the depth buffer and the normal buffer available to you.
Mm-hmm.
But if you don't, you could use like a simple script. It's a really simple script that the only thing it does, it activates the camera depth buffer. So nothing really special about here.
Yeah, but quite useful.
Yeah.
So yeah, go for it.
So let's start. This is the fire one. I'm going to create a new shader. Let me just deactivate the old one. I'm going to create a new cube. Let's leave it at that. And I'm going to create a new shader. And it's going to be based on an unlit version of the shader, so you don't need any kind of lighting information. So we'll use the default unlit. Let's place it somewhere around here. And let's start. So two things that we want. We want to configure one of the parameters that's really necessary is to be able to always render the cube on top of everything else. And we do that by making sure that we are always rendering on top, and that we want to actually invert the code facing, which is usually set up to be on the back.
Mm-hmm.
So in this case, I'm going to change it to be on the front. And I'm going to deactivate the Z write mode to off. So I'm telling it to not write to the depth buffer, and I'm going to always run the back faces. And to make sure that it's always rendered on top of everything else, I'm going to change the Z-test mode to always. So this is the basic setup. Let me just create a material for it and place it on the cube. So yeah, very simple stuff. Is only rendering a white cube for now. So the next part of this trick is to use a node that we called reconstructs world position from depth. I'm not going to actually explain what this does, but the idea, or at least not in a very specific way, but the idea is that it reads from the depth buffer and tries to reconstruct the world position from whatever the depth buffer is. So you are actually calculating the world position from everything that it's behind the object.
And this is actually a shader function.
That's right. So I can actually double click to see its content. Like I said, I'm not going to explain every little thing that it's here. You could check it out, maybe learn from it. There's some matrix calculations involved here, so it's a little bit more complex. But for now, let's just connect the node to the output and see what we get.
Cool. Let's just make a small adjustment and kind of resize the webcam window here.
Yeah.
Oh, or pull that. Yeah, fixed.
Yeah, it works like this.
Because last time I think we kind of covered some info on the output node, but that's all right.
Yeah. So just to recap, so the cull mode is set to front, the Z write mode is set to off, and the Z test mode is set to always. So that's the three things that makes it always rendered on top. And then you use the reconstruct world position from that node to render the world position from whatever it's behind. So you can see right now, well, let me just deactivate the post-processing for now. So as you can see, the cube is always rendering the world position that for whatever it is behind. And even if I go inside the cube, because I set my cull node to be at front and not at back, it means that it's always running the back faces. So even if I'm inside the cube, I can still see the contents of whatever it is behind the cube.
Yeah.
So this is the important step. So now the trick is to actually use this world position to calculate like a distance to a point. And with that distance, we get like a sphere that you can think of it like an influence sphere. And we'll use that sphere to actually paint the surrounding area. And this will paint on top of everything else that you have that writes to the depth buffer. So for example, if it's like an opaque object, it will get the effect, but it's like a particle system that it's transparent. It will not, because it's not writing to the depth buffer. So it's a very important step that this only works for opaque objects and not for transparent ones. So in this case, the idea here is that you use the lerp function, the length function, but before we do that, we actually want to transform this reconstruct world position from depth, which you can think of it, right now it's giving you the world position. We want to change this to something that works on local position, on local space, because we want to be able to then change the cube position, rotation, and so on, and we want this world position to always follow the cube and not be staying around like it's doing right now. So we will use the transform position node, and we'll change it to world to object. So you can think of it like you have a world position here, we are sending it to the world position input, and we'll receive an object position input. So now, as you can see, it stays with the cube, the colors, while before they were sticking to the middle of our scene. So yeah, so now if you do a length here, and I'm using Alt drag to drop my node between the line, you can see that we get like this smooth gradient, as you can see. And all we need to actually do is to invert this gradient and to clamp it, only to make sure that we don't blow out the remaining area. Let's try it out. So I'm going to use the 1- node, so you can see the results. Let me just change this to material mode, and I'm going to use the saturate node. This is only to make sure, because this black area is actually negative right now, so we want to clamp it to be 0. And as you can see, the sphere, it's a little bit too big. We actually need to scale it down a little bit. So we do it by scaling down the world position by doubling it. And this is the main effect. So right now, you can see that it's following our cube. But we actually don't want to have a black cube with a white inside. So we want this to be transparent. So we need to change again our configuration here. So right now the blend mode is set to off. The way we can fix this is by simply setting it to pre-multiplied. You could set it to alpha blend. I only prefer pre-multiplied because it gives you a little bit more contrast when you deal with parts that are dark and parts that are white or a little bit lighter. So in this case I'm going to use pre-multiply, and the rule of thumb when using this mode is that wherever you put inside the frag color, you need to pre-multiply it, or in other words, you need to multiply it by the alpha content. So I'm going to use the append node to define what's alpha and what is color. So right now I'm going to say that this is alpha, and I'm going to give it a random color for now. Like it could be red, for example. And like I said, I need to make sure that my alpha is multiplied by my color. So, and this is only in the situation that we have a pre-multiplied shader.
That's good to know. I actually didn't know that.
So yeah, so now we have like a glowing red sphere that actually touches every single object, or at least at every single opaque object.
Opaque object, yeah. I can already see the potential for something like this. Yeah, simple, but
so now let's spice it a little bit. So the idea behind doing the fireplace, or the one that I showed you earlier, is that we actually use a gradient instead of a single color, and we actually make it flicker by increasing the size a little bit using a scene time function. So instead of using this color, I'm going to remove it, and I'm actually going to use the gradient node and the gradient sample, and I'm going to use the my alpha here to drive my color, and for my gradient I'm going to do like a blend between red and like a yellow or orange, so something like this. So this is already starting to look like it's a burning fire.
Cool.
I'm going to once again turn on my post-processing stuff. Let me.
You guys enjoying the effect so far? You're very quiet today in the chat. Don't be shy. If you have any questions, just drop them by.
So now that we have this here, the only thing that it's missing is the flickering effect, and we do that by using the time node and passing it by a scene function. So if I do something like this, and now I can influence the scale of this by for example using a power function after the length. You could actually do it after one of these others, but I find it more pleasing doing it here, at least visually. If you do it like this, for example, if I now save it, and you'll see that it starts to go back and forth between -1 and 1. Of course, that it's going to values that we don't want, for example, this kind of values, because right now it's inverting the mask, so it's showing the cube and not the sphere that we want. And we need to change this a little bit. And we can do that by, for example, doing a scale and offset, because we know that the result of the scene function actually is going from -1 to 1. So we can just scale it down by half. Oh, not this one. Let me just, so scale it by half and then add another half. So now it will scale down to 0, and it will scale up again to the full potential. Of course, this is not really what we are looking for, because we don't want the burning fire to extinguish and then reignite every second or so. But what we can do now is that we can actually use multiple times or multiple sine functions together and make it like it's flickering. It's not actually random, but it will look a little bit random. So the idea here is that we want to use not one, but actually 4 of these, and I'm going to do that by using an append function again, or append node again, I mean, and I'm going to multiply this a few times.
Cool. Thanks, Silver. Glad you liked it.
And for example, I'm going to do I don't know, just kind of random numbers.
Stick around, we're going to show another type of decal, if time permits, near the end.
Yeah, we'll do some caustic effects. And we want to be able to multiply these together, so I'm going to break it down. What I'm doing here by using the append and then breaking it down again is only saving some extra instructions, because instead of doing this for every single one of these, I'm just using a vector 4 to do the operation on all of them at the same time. So now that I have these all together, I can just multiply all of them. And I could even have a property to control it a little bit more. So like, I don't know, intensity maybe. Something like this. Let's see.
Oh no. Oh, there we go.
So what we are seeing here is the sum of all those frequencies. We need to actually use some better frequencies so it doesn't look this weird. I have some set up in my other monitor that you can see, but I'm going to use some values that I found that work okay. So, and we actually need to do some offsetting. So right now, when these values go to their -1 value, or in this case, because of our scale and offset, they go to 0, they actually end up almost deleting the effect. So by doing like a little offset of the value, we can actually try to correct this. I'm going to just add on each of one of these a little number. Just make sure that they go a little bit above 0. Something like this. And to make sure that this, well, it's not to make sure, but we're already scaling it to a point where we are comfortable, but you can actually scale it a little bit further down and move it a bit more up. So, or in other words, right now we have a -1 to 1 value. That's the range of the sine function. But we can change it to, instead of being 0 to 1, to be like, I don't know, maybe 0.5 to 1 or something like that. So by doing a different scale here, and by doing a different offset,
that's going to increase the length. Or
no, it's going to define a higher range of values, so they don't never go to 0.
Yeah, the difference is pretty obvious.
And you can even change it. You can see that the sphere is a little bit too harsh on the sides here. You can change this by using like a smooth step function, or doing another power node to this alpha here. So I'm not going to, but you could experiment a little bit with it. So
yeah. So we have someone asking why wouldn't clamp be better, and said, if
instead of saturate, for example.
So saturate is actually quite helpful if you want to explain.
Yeah, so the difference here is that we, at least in the case of the saturate, saturate is the same thing as a clamp. Actually, when you compile a clamp node that has a range of 0 to 1, it will actually convert it to equivalent to a saturate node. But the reason we didn't use a clamp here was because we don't want to clamp the values that are negative. We want to use them in the sign function, but we want to change or remap these values to a new range between something that we can actually see. So you don't want to like clamp it to, for example, let's assume that we would clamp it. Let's say.
Hey Patrick, welcome. Good to see you, man.
Let's say that instead of using the scale and offset, I would use the clamp. What would happen is that for some time you would see the result being negative, and it would stay dark for a very long time, or at least for the time that the scene function is negative. And then they start increasing again to values that are positive, and you see these flashes of light that don't make sense. And that's why you don't reuse the clamp here. You use the scale to remap these values.
Hey Miguel, thanks for joining.
So yeah, this is the primary function of this stream. But now I'm going to show you another way to use this technique that is a little bit more complex, but also a little bit more cool, I guess. So right now I'm using this sphere and using the gradient node to do this kind of sphere that glows. But now let's see the caustic effect. So here I set it up like a box with some spheres, and I'm going to show you the caustic effect. So right now what you see here, it's the very basic, the very same technique that you saw on the sphere, but right now this sphere is also driving a projection of caustic effects. And what you see here is actually the Voronoi node that we added just a few months ago. And we have like this option that we call it caustics, which is basically the visual effect of the Voronoi already looks like caustic, so I'm using that to actually render caustic effects.
Or maybe it's plasma, we don't know.
Yeah.
Can you just move this? Oh, hey Patrick. Well, if you have a question, you can just drop it there and we can answer near the end of the stream.
If it's related to this one, we can answer it right now, but if it's for something else, we can answer it later.
Yeah, totally.
So as you can see, I have this, let me show you the box. I have this huge cube, and it's actually projecting for wherever it's touching, and I can rotate it. I can scale it down or up, for example, like this.
Oh yeah, works a bit differently, but it's flexible. So yeah, Patrick is asking, I don't know if you can answer this now, but can we filter the Omni Decal to affect only facing normals? Only the facing normal, like an Omni light with shadow?
Yes, in fact, that's what we are going to do on the caustic effects. As you can see on this sphere, for example, it's being affected, let me deselect. It's being affected on the top, but not on the bottom. Let me. So we are going to use the normals of the world to actually know what we want to paint over. However, there's a small caveat to this, is that we can't, at least not easily, we can't do like a shadow projection. So for example, right now the sphere is being painted with the caustic effects, but below the sphere is also being painted with the caustic effects. It's not actually doing like a shadow effect. It's a little bit of a limitation here. We could do like calculate like a render texture to then sample it to be able to do like some shadow mapping, but that's far too more complex than just doing this kind of effect. So let's now do this one. I'm going to.
Hey Andreas. Oh, thanks Patrick.
I'm going to again create a new cube. This time, let's for now scale it to 2. And let's create a new shader. Again, it's a unlit one. Same thing. You could even duplicate the other one, but let's start again.
It's alright. Start fresh.
Yeah. Let's create the material. Assign it to the cube. And let's see. So we need to, like I said before, change a few things. We need to deactivate the Z-Write, and we need to set the Z-test to always. This is to make sure that it's always renders on top of everything else. And we need to change the color mode to front to be able to be inside the cube and still see the projection on the other side. This is for the rendering of the reconstruction of the world position, I mean. So this is the world position, and now we also need to change this to be a transparent shader. So in this case, we want this to be a pre-multiplied blend mode, and again, we need to define what's alpha and what's the color. So again, I'm going to just copy this part here. So as we saw before, we are transforming the world position into object position just to make sure that it follows the every rotation and scaling of the object. And we are going to do a length to do that sphere effect. So roll to object, scale it, and then do the length, and this will be going to be our new alpha. And let's paint this with the not this one, like whatever, something like this.
So yeah, in case you just joined us, we've just created a Omni Decal for like an amplifier effect, and now we're doing a planar decal.
Yeah.
Sort of caustic effect.
Yeah. So I'm missing the inversion and the saturate. So in this case, the 1- nodes and the saturate nodes. So something like this.
Just to point out that being a shader function there for the reconstruction, you can actually use it anywhere you want. That's the cool thing about shader functions.
And because it's a pre-multiplied shader, we can't forget that we need to multiply our alpha with our color before sending it to the final results. Okay, so we are back on the start of the last sample. We have the sphere. It's projecting correctly, so on every direction, even with the spheres here. Okay. So now we want to be able to project it on some sort of direction that we want to define, and I'm going to arbitrarily define that this direction is from top to bottom. So I'm going to say that it's going to be on the y-axis from top to bottom, and I'm going to then project like a texture or something like that, and then we'll move to the caustic effects. So for that, I'm going to need to also change the world position into something like something that we can use to define a direction. So for the sphere, we use the transform position and node to transform the position from world to object. And now we are going to use the transform direction and also transform it from world to objects. And this will give us a vector that it's in object space, at least in relative to the cube itself, that contains the direction of the position, but in a way that we can use it to filter some side of this projection. And that's what we are going to do, and then we are going to use that position to drive a texture. So in this case, I'm going to place a texture, and let's say that without doing anything else, I'm going to just use the X and Z components of this direction, and I'm going to use this as my color, and let's place like our logo on it, for example. So
nice. Already see something.
you can see that it's working, but there's still a few issues. So in this case, the position, or better yet, the projection of the texture is always fixed on the floor. We could, for example, do some changes here just to make sure that it stays on the cube. But because we want to do the caustic effects, we actually don't need. So this is already working for us. The only issue right now is that there's some issues that could arise from, for example, scaling this. So in this case, if I scale my object, you can see that it also scales the texture inside. So I'm going to do just a small fix by multiplying this direction by the object scale, which is a node that we can, not this one. Whoa. Whoa. Object scale. And now you can see that it follows, or at least it stays at a constant size independently of the scale of the object. So even if I do like a 10, it stays at the same size.
Cool.
So that's the only thing we need, at least for the caustics. And now if I replace this sampler here by the Voronoi nodes, let's see. We no longer need the sample. Just default options. Let's see what we get. So it's working, but it's not there yet. The issue here is that our we need to change the scale and some of the options here. So for now, let's see. For example, I think 5 may work. We can even do something else. We can use a property to define a scale. So let's see, 5. And yeah, it's there. Let's also tint this. So like a blue color or something like this. Okay. And now you can see that it's working. Something is still a little bit. No, it's working. Yeah, it's working. But I'm going to change the type of Voronoi that we are using to do that caustic effect. So instead of using the Euclidean distance function, I'm going to that's not the one, the method one. Yeah. Instead of the cells, I'm going to use the caustic. And as you can see, it looks a little bit like a caustic effect. However, it's not actually moving, which is not really interesting. But there's a simple fix. We can actually do or create a time node and place it on the angle input, because this is the input that controls how the caustics move around. So just by placing a time node here, it will start to move.
Cool.
So let's see. If I rotate this, it's working. However, let's place this not here. That was a little bit too much. Let's also increase the size. However, you can see that the backside of the sphere is still being lit, and it creates these stretches on the sides because it's finding a perpendicular or a parallel surface from the projection. So it looks like these streaks that you can also see on the wall. And we can fix at least these ones. This one's a little bit more complex to solve. Usually I just rotate a little bit just to make sure they don't show up. But on the sphere, by using the normals of the world, we can actually filter the backside, and those streaks will disappear. So let's now start creating the final part of this shader, which is to filter this by the normals. Let me just group this.
Just one quick question here.
Yeah.
Is it possible to hide these decals behind specific objects? I think it means covering the decal, perhaps?
That's actually a really good question, because I was going to mention that at the end. There's some limitations to this technique. You can solve it with some shader techniques as well, but right now if I want to paint just the interior and not the other side, the normal will fix this side because it will detect that this normal will be on the other side. So you won't see the caustics on the other side of the wall, but you'll still see the caustics on the floor, which you might not want it for some reason. Yeah. It may be bleeding to the wrong side. And if that's the case, you can mask it by using or some other kind of function that you can define, like for example a range, and create like a sphere to mask it, or you could create like a box, or maybe I don't know, maybe you could do something like detecting the Y position, or
would our box and sphere mask shader functions work, for example?
I didn't test it. I guess they could. Let me just check.
That'd be something interesting to test, Andreas.
Yeah, they probably work. I didn't test it, but
that's all right. Maybe for the end of the stream.
Yeah, you can test it at the end, and then you can, for example, let's say that this is my pool, or better yet, this is not a pool. It's an how do you say it? Aquarium.
Aquarium.
Yeah. Sorry, not gonna try it. Say it again.
I'm kidding.
And let's say that this is like glass, and we don't want the caustic effects on the floor. Yeah. You could then use I'm guessing the box mask to filter the result outside and not display it like this. But for now, let's just do the normal stuff, just to filter this part of the effect.
The streaks, you mean?
Yeah, the streaks and the fact that it's showing on the other side of the normal. So for that one, we need to do a little bit of manual work. Something similar to what we are doing already inside this node. As you can see, we are sampling a texture here, so the camera depth texture. We now want to sample another kind of texture that we can use, which is the depth, the camera normals texture. So similar to the camera depth texture, but now it's for the normals. So we'll do it manually by just placing a texture sample, and by saying that it's a global property.
Yes, Patrick. Todos falamos português aqui. Kinda.
And then I think it's called camera. Let me consult my camera normals texture. Yeah, like this. And if we now use the screen position in normalize modes, you can see that it's already giving us something here. So this is going to be our normals, and we also need to do some math here, some transformations here, to make sure that it follows the projection of our cube. So in this case, we need to first do some math on the normals, because right now these are, I believe, in the 0 to 1 range. So we want to remap it to -1 to 1. So we need to scale and offset this.
Hey Polytoots, welcome. Don't worry, the DVR, the video of the stream is going to be available right after we finish, so you can catch up. But so we built an Omni Decal like we announced, and now we're doing a planar one.
That's right.
And Paulo will go over it once we're done. He'll kind of explain what's going on. So
I'll do like a small rundown.
Rundown
of the of all the things we did. So right now I'm going to I already remapped the values from 0 to 1 to -1 to 1. And now we are going to again use the transform direction nodes. And the reason we're going to do this is again because our normals are in world space, and just like we did on the Voronoi here, we are going to change them to world to objects, from world to objects. And just like we did on the transform the Voronoi, we are going to make sure that we also multiply it for the object scale, so it respects our scale and not just the rotation, because this is a node that only transforms directions. Okay, so by doing this, if I now just check the insides of this, let me just, for example, not here, sorry. So as you can see, this is the normals we are getting. This is the normals. Let me show you the normals that we get on the texture alone. And as you can see, they don't really look like normals because they are on the 0 to 1 range. We then map it to -1 to 1. And we then do the transformation just to make sure they align with our cube here, which is our projector. So, and this is the result. And I don't know if you can tell, but right now the Y or the green parts of the normals is aligned with our Y, local Y direction of the cube, as you can see from the gizmos here. So what we want here is to filter the content of these normals and only retrieve our Y direction. And as you can see, it's giving us this red because it's not really mapping to the correct.
It's a good one, early gamer. It says we're building an amplifierium.
Amplifierium. So yeah, this is our normals projected. If I now move or rotate the cube, you can see that it follows the cube correctly. And the only thing that it's missing is you can see that it's going in black because it's the values of the normal are going from -1 to 1. And we can simply either clamp it or do some kind of math. We can even do the inverse of this operation. For example, we could do like the inverse of this operation would be 0.5 to 0.5. But this is not really what we are looking for. We only need to clamp it. We could use the saturate node. But I found it to, I used the saturate node a lot, but sometimes when I don't like the harsh transition between the light and the dark part, I do the smooth step, and due to the way the smooth step works, it already works or acts like a saturate, so you don't need the saturate in the end. So it's a lot much smoother now, the transition. So yeah, now it's filtering correctly, and the only thing that we need is to stick the rest together. So something like this. Let me just bring this a little bit down here. Let's call it just color here. and it should be working. Let's see. Not this one. Sorry about this. Okay. So as you can see now, it's not affecting the other side of the sphere. And not the other side of this wall. Well, it's doing, yeah, it's doing something here, not sure why. But we could filter this out a little bit better by using the normal. This is where the box sphere, the box masks comes in. So let me just delete this. And let's group this together. So just as a recap, this creates the sphere that projects. It's not projecting, but it paints a sphere in every direction. This actually projects in the y local direction of the cube a Voronoi effect that has the caustics turned on. I actually found that if I now show you the other result, there's a cool trick that you can do now as well. Let me just maybe show you right now. This is the one that I've already prepared before. If you, instead of using, let me just bring the shader here. I already prepared this shader before, and you can do some other kinds of work. For example, instead of a sphere, you could do a square. As you can remember, the sphere was you do the length calculation, and instead of doing the length, if you instead do well, an abs followed by a break to components and max out the results, you can actually do a box. So
cool.
So now it's a box and not a sphere. And this could work, for example, if you want to do the caustics inside a square pool, for example.
In an amplifarium.
Amplifarium,
yes.
That's right. And another thing that I found out to be really cool is that we recently added to the Voronoi a new kind of feature, I guess, that if you choose the cells, the original cells, you now have this smooth option. And if you use that option, I don't know, I think the result speaks for itself. So it's kind of like a more stylized caustic effect. So yeah. It's
could be a lot of things. I really like it. It's cool.
And you can control the smoothness in real time.
Very cool. Very cool.
So yeah. That's that's what I had prepared for you today. Let's recap a little bit. So I'm going to show you the bonfire again.
So if you guys have any questions, now would be the good time.
Yeah.
A good time for them.
This is the final results for the bonfire. This is our effect, the one that we constructed. You can add like I added like a particle system here and a point light just to, I don't know.
And the post effect, right?
Yeah, and I added the post effect, that's right. So you could increase the intensity and do some crazy stuff. I'm not going to, but I was going just for like a smooth effect instead of something that aggressive. But this is our bonfire, and this is our pool. And like I said before, this works on every opaque object, and because it works on every opaque object, I can even blend them together, and you'll see the results blending together.
And is this mobile friendly? Early Gamer is asking.
Okay, so that's an interesting question. I didn't really do like a stress test, of course, but because if you use projectors before, Unity projectors, they usually render a draw call for each surface or each material per light. So that means you can easily get like 30 or 40 draw calls if you have like a lot of items being affected by the projector. And because this is only a single cube with a shader, it's only rendering one draw call. So you can basically do kind of like a light effect with just one draw call.
That sounds very useful and light.
Yeah.
I would, just out of curiosity, would the noise nodes be kind of heavy for mobile, or is that something that's manageable?
You can, for example, replace the Voronoi with the texture, or two textures being multiplied together, panning together, to create the caustics to make it a little bit more mobile friendly. But yeah.
Awesome. Early Gamer, if you do build a shader, you can drop by our Discord and show it in our showcase section, and we'll tweet it out. So yeah, looking forward to it.
Let's just review the shaders themselves, just a little bit. So actually, let me show you the one that I've prepared before because it's a little bit more tidy. So this is the circle. So we do the reconstruction, transform it to object space, and then do the length. And this is the part where we do the glinting effect or the bonfire. So we do the 4 times scale differently. Then we offset them a little bit, pass it by a sine wave function, and we scale and offset to make it on a range that we can use, so they always stay a little bit lit. And then we can, I actually added this on my previous, I had this ramp fall off that you can increase or decrease here. So, and then we use the gradient sample. You can even use a texture. So I've prepared before this texture here. So it's I can show you the texture. So this is the texture. And you can use the texture instead of the gradient sample if you think it's it's convenient for you to use like something that you can create on Photoshop or something like that.
Awesome. I can finally build my cyberpunk scene.
Yeah. So yeah. Not this one. What did I do wrong?
Oh no, you broke it.
Okay. Okay. This is the more simple one, and for the caustics, let's see, the caustics, we have the circle part, which is basically the same as the other one. We have the caustics projection, where we transform everything again, now not the position but the direction, to then sample the X and Z coordinates, and we do the Voronoi, and we do the sampling of the camera normal textures. That, remember, you need to have this texture available, which may not. So I'm forcing it by using in deferred mode. Sometimes if you use in forward, you may not have it available. That's when the force normal script that I showed you earlier comes in, just to make sure that you can have this texture available to you. And we scale the normals, transform it to the object position, and then we get only the Y coordinate, or the Y side of the projection, just to filter out the other side of the normals. So yeah, that's the final results. If you guys have any questions about this one or any other, yeah.
Awesome. Turned out really, really great. And actually, it was simpler than I expected. I thought you were going to do a lot of calculations there to get it projected, but... To
be fair, the most expensive ones, or the most complex ones, are the inside of the...
Oh, they're all hidden.
They are inside of this node, so...
Well, that's the good thing about shader functions.
Explaining this would be a little bit harder, so there's a lot of matrix work here, so...
Yeah, maybe some other stream we can can go in depth. But yeah, that's pretty much it. So we hope you guys enjoyed it. And Polytoots, we're also looking forward to your flow tutorial. I don't know if that's out already, but looking forward to that.
I'm actually planning to do a water sample.
Using flow.
Yeah, using flow and stuff like that. So
it'd be interesting to see how they work. Awesome. So yeah, that kind of wraps it up. We're gonna be going live again in about 2 weeks, probably.
Yeah,
every 2 weeks. So until then, if you guys have any requests or if you have any questions, just drop them by at any time, and we'll try to prepare something more going towards what you need to see, because we've been kind of deciding what would be cool to do, but we're kind of open to any ideas.
yeah, I'm constructing these samples, but I can easily construct something that someone's request instead of thinking. I don't know. I only did these ones because I thought they are cool to use in your projects, but there's some other more complex. For example, even if it's not really a sample, but how does this work, or how you can do something inside Shader Editor? I can do something different. Yeah.
Even if it's technical, but if it's something we can explain, or Paulo here, he'll get to it. So awesome. Thanks, guys. Thank you, Polytoots, Patrick. We'll see you on Discord then. Thank you all for watching.
Bye, guys.
Bye. Do you want to do the honors?
Yeah. See ya.
Bye.